Why am I bouncing this ball? Well, I'm demonstrating conservation of energy, or energy transfer as it's sometimes called. Now remember, previously we had conservation of matter. Remember when you were balancing the chemical reactions? Remember that the same number of atoms on each side of the reaction had to be the same. Matter has to be conserved, cannot be destroyed or created, just transferred in form. Same thing with energy. The universe has all the energy it will ever have, and it just changes one form into another. So something as simple as bouncing a ball is actually a complicated chain of events where one type of energy is transferred into another type. If I hold the ball up here, it has what we call gravitational potential energy. Gravitational because you know what's going to happen if I let go, gravity is going to make it fall. Potential because it has the potential to fall. It's not falling right now, but if I let go, it has the potential to fall. So when I let go, it does indeed fall, and it goes from being still to moving. Any object that is moving has what we call kinetic energy, the energy of motion. So the gravitational potential energy is being converted into kinetic energy as it falls. Now, as it falls, it's moving through the air. So there's a little bit of friction between the ball and the air. And friction is associated with thermal energy, or the energy of heat. I want you all to do the following experiment. Ready? Come on, do it. Come on. Yeah, you. Come on, do it. Hopefully by now your hands are very warm. Actually, that feels pretty good. What's happened is that in rubbing your hands together, you have friction, and that friction is going to change some of the kinetic energy of the motion of your hands into thermal energy, into heat, and that heats up your hands. So I'm not saying the ball is going to get as hot as your hands when you're rubbing them against each other. That's not what I meant. But a little bit of the kinetic energy is being converted into thermal energy because of the air resistance, because of the friction between the air and the ball. Now, hits the table, right? Hear that? A little bit of that kinetic energy is converted into sound energy. And when it hits the table, there's also a little bit of friction. So there's a little bit of thermal energy being transferred between the table and the ball. But what's also happening, if we did it in slow motion, is the ball is compressing. The compressing of the ball is storing what we call elastic potential. Right? And then what's going to happen is that elastic potential, when the ball springs back, the elastic potential is going to be converted back into kinetic, and the ball is going to go up again. So why doesn't it go up as high as I originally dropped it from? Well, let's think about it. The gravitational potential energy is being converted into kinetic energy. But not all of that energy is in the form of kinetic, right? Some of it is in the form of the air resistance creating thermal energy. So the total amount of energy you had to begin with, on the way down, some of it is converted into thermal energy, which goes away. So when it hits the table, some of the energy has already gone off. And when it hits the table, some of the energy goes off as sound. And some of the energy goes into the thermal energy because of the friction between the ball and the table. So not all of the energy that it started with here is going to be converted into the elastic energy, which converts back into the kinetic. Some of it has gone elsewhere, has been transferred into thermal and into sound. So that's why the ball doesn't go as high. Now the total amount of energy, if you add everything up, is the same. It's just that some of the energy has been converted into a form that has gone elsewhere. And that's why the ball doesn't go as high on that bounce.